Greetings, my name is Don Mabey, and I am the Director of Marketing for the Quick Install Frame System. The information in this presentation is focused on the lean construction concept of analyzing and improving value-added activities. Every construction project has two common features, walls and door openings. Frames and doors are then assembled with hinges and screws to complete the wall assembly process. This sounds rather simple, right? The fact is, when you swing the door to complete the final assembly, this is when you find out if the assembly is perfect. Many times, it is not perfect. The solution is to adjust the swing. Adjusting is a non-value adding process to describe when a defect is discovered and it needs to be fixed. This presentation will show you a process to significantly reduce or eliminate the need to make adjustments after assembling the door to the frame. So what is first-time quality, or FTQ? It is simply do it right the first time. It is a calculation of the percentage of good parts at the beginning of a production run. It is a measure of how well the process performs when you hit the green button to start. It is an indication of a well-designed, validated, and managed process. But can FTQ be applied to the results of a construction process and project? Take a look at the punch list of a recent project. This list will show you the number of operations and processes that did not achieve first-time quality. How can you make a door frame installation perfect every time? There is an alternative to eliminate or minimize the adjustments needed to increase first-time quality performance and achieve a perfect door and frame installation. The solution is this simple. It's a slot pictured here. Okay, so now that you know the answer, let's take the time to learn how this simple slot was engineered into a new process for installing a welded hollow metal frame perfectly every time. People pass through hundreds and maybe thousands of doors openings every week. If the door is a commercial metal door like this one, most people never look at the door and frame. However, if you are a carpenter or in the construction business, you know when an installation is perfect and when it is not. This is a photo of a perfect door and frame assembly. Look at it. What can you see that makes you believe it is perfect? The obvious answer is there are no blemishes and the reveal gaps are uniform. The final quality approval may simply be a visual judgment along with opening and closing the door to confirm proper operation. However, to be more precise, there are industry specifications which provide dimensional tolerances for an acceptable gap. As we all know, nothing is perfectly identical in a manufacturing and assembly process. So dimensional tolerances allow for a range of dimensional variation, which is acceptable. Anything above and below the acceptable tolerance range is unacceptable and must be rejected and corrected. Certainly, you can measure every gap exactly, but in general, visual judgment is an acceptable initial criteria for approval. These drawings are good examples of potential problems involving reveal gaps between the frame and the door. If a defect is identified, actually measuring the dimensional issue can help define the extent of the problem. Customer quality expectations match the definitions showing on this page. Therefore, all frame and door assemblies must be perfect for the customer to accept delivery of the building. You don't argue or debate with a customer about what is acceptable. That's because you identify and repair a problem before the customer sees it as a defect. According to the 8 wastes of lean, repairing defects is a non-value-added activity that should be recognized and eliminated. So the question becomes, is it even possible to complete a perfect frame and door assembly the first time? How about every time? Which of these possible answers would you select based upon your experience? Here is an obvious and horrible example of a defective frame and door assembly. I didn't go looking on the internet to find this photo. I actually stayed one night in the hotel room where this was the entrance to the bathroom. So what went wrong? For people not familiar with frame and door assemblies, they might ask, was the door slab dimensionally incorrect, not square? The answer is no. The door slab is manufactured correctly with close tolerances. The next question would be, is the frame constructed out of tolerance? Once again, the answer is no. The manufacturing process is under control with consistent and close tolerances and no variation. So the problem is not material related. Therefore, we need to consider other potential root causes. Because the defective installation condition shown in this example does not occur 100% of the time, we need to consider the effect of variation on the installation process. Since the doors and frames are both manufactured within design tolerances, the next point of investigation must be the opening in the wall structure. Specifically, was the opening constructed properly and within specified tolerances? Proper frame installation must be investigated to confirm it is both plumb and square. In addition, there could be another cause outside of the process to consider. The frame can potentially be damaged by other trades during the project build. If the frame is obviously damaged, that would be repaired early. But there have been incidents where a frame is pushed out of plumb during the drywall process and the problem is discovered when the door cannot be installed properly. Process variation automatically increases complexity, and complexity has a negative impact on process repeatability. A contractor would naturally respond by saying, "We can't control variation. The architect controls the design." However, we know how to overcome problems caused by variation. Your company is different, right? Therefore, since your company has a reputation for quality and achieving customer expectations, your response may be, because we can't control variation, we have to accept what defects will occur, and we will repair those defects to make it perfect. It becomes one more thing to add to the punch list. But this also brings up another thought. Why is the root cause never addressed to improve the process and eliminate the problem? Could it be because this is the way we've always done it, and therefore there's no motivation to change? These two potential root causes could be classified as craftsmanship or skill issues, since they are under the control of the carpenter. Typically, the corrective action for issues involving skills or craftsmanship is to conduct training to improve performance. Investing in training is always a worthwhile plan. However, if the training is aimed at repairing defects, like this example of how a carpenter could add shims to throw the hinge position to improve the frame assembly reveal gaps, then you are not training to eliminate the problem. Instead, you are training how to add waste to the process. In this example, this repair is impacting 3 of the 8 wastes of lean construction, specifically defects, motion, and extra processing. In order to build a perfect structure, you must have a perfect foundation to start with. The wall studs and the door opening are the foundation for traditional frame installations. If the studs in the opening are built outside of the specified tolerances and are not plumb or square, then the door and frame assembly will not be perfect. You may be asking yourself, what are dimensional tolerances and how do tolerances affect installing a frame and door assembly with a perfect reveal gap around the door? This chart is a standard deviation curve showing the distribution of a range of numbers. This is the standard bell curve used in school to illustrate the distribution of grades. For purposes of this discussion, the range of the data is plus or minus 250 thousandths, or 1/4 inch, shown on the blue line. Plus or minus 250 thousandths is the tolerance range from the mean dimension for a wall opening to be within tolerance. This is represented by the vertical line in the center of the curve. The two vertical green lines represent the tolerance range for the reveal gap between the door and the frame. With this information, you can see that openings shown in red, which are within the construction tolerance but outside the tighter tolerance range, will potentially be a problem for the carpenter to achieve a perfect reveal gap every time. So what is the answer to eliminate the problem? The answer is reduce process variation. Remember this image from the beginning of the presentation? Now that you have learned about how variation and dimensional tolerances can have a negative effect on a carpenter's ability to complete a perfect frame and door assembly without additional adjustments or tweaking, let's learn about how this slot design feature improves first-time quality performance. The quick install frame is installed after the wall is constructed and the drywall has been installed. Remember, the opening in the wall is built with a dimensional tolerance range of plus or minus 250 thousandths. This dimensional tolerance is satisfactory to achieve 100% first-time quality results for the opening. However, this broader tolerance range will not guarantee a plumb and square opening, which is needed to achieve a consistent 1/8 inch reveal gap in the frame and door assembly. The critical foundation of the quick install frame system is the 16 gauge formed steel mounting plate shown on this image of step 2 in the 6-step installation process from the quick install installation instructions. The plates are installed level with each other and anchored to each side of the door opening with screws passing through multiple slots as shown in the photo. Once they are in place, the carpenter adjusts the mounting plate to be perfectly plumb and then tightens the screws to hold the position in the slots. With the mounting plates in position, you now have a perfect, stable foundation to attach and lock the frame into the opening within a dimensional tolerance range of 1/16 of an inch, which is 1/4 of the 1/4 inch or 250 thousandths range of the opening. The variation has been significantly reduced, thereby improving the ability of the final assembly to be 100% perfect the first time. Clearly, the adjustability of the mounting plate using this simple slot design feature provides the carpenter with the ability to construct a perfectly plumb foundation for the frame and door assembly. The dimensional variation of the opening has been substantially reduced, making first-time quality performance automatically increase. With the mounting plate foundation securely installed in the opening, the active frame component is ready to be pushed into the opening. Each side of the frame has 4 mounting brackets welded in place. These brackets align with the matching riveted studs to guide the frame into position. Once the frame has slid into position on the studs, the carpenter pushes a stud lock clip into the position to securely lock the frame into the opening and firmly push the frame against the mounting plate from top to bottom. The frame is perfectly plumb, square, and ready to have the trim frame pushed into the back of the opening. The final step in the frame and door assembly process is to mount the door to the frame and with the hinges and the screws. Because the frame is perfectly positioned, the proper reveal gap is created every time without any need to adjust or throw the hinges. First time quality is achieved, this frame has not been added to the punch list. Because the frame can be installed at the time the door and hardware are installed, trade damage is reduced to virtually zero. Variation has been reduced. Waste has been eliminated. Total labor has been reduced by at least 37%. The customer is satisfied. Profitability has increased. Done.